In this video, we'll be going over how to find coterminal angles in both radians and degrees. First off, let's start with degrees. So first we're going to lay out the rules, and as we said, these are for degrees. So when you are trying to find the coterminal angle in degrees, you can add or subtract multiples of 360 degrees, multiples of 360 such as 720 and 1080. Next rule is that your coterminal angle has to be between 0 degrees and 360 degrees. These are the two main rules for finding the coterminal angle in degrees. Now let's go ahead and do some practice problems. So our first practice problem is going to be to find the coterminal angle for negative 860 degrees. Now, as we said before, we can add or subtract multiples of 360. Now, if it's a negative number and we want to get it between 0 and 360 degrees, that means we should probably be adding. So let's add 360 degrees. So negative 860 plus 360 is negative 500 degrees. Now we can obviously see that this is not between 0 and 360, so we're going to continue adding 360 degrees. Now we have negative 500 plus 360 degrees. Negative 500 plus 360 is negative 140 degrees. We're pretty close to 0 now, so we can add another 360 degrees, and we would get positive 220 degrees. And we can see that we have been adding multiples of 360, or 360 itself, because 360 multiplied by 1 is a multiple of 360, and it is just 360. And that's what we have been adding. Now, we have already satisfied step 1, which was adding multiples of 360. Now we need to make sure that we have satisfied step 2 as well. Step 2 says that our coterminal angle, must be between 0 and 360 degrees. Well, 220 is greater than 360, and it's less than 300. While 220 is greater than 0 and less than 360 degrees, meaning that we have satisfied both rules, and that 220 degrees is the coterminal angle of negative 860 degrees. Now, we're going to do one more practice problem in degrees. So, in this practice problem, we're going to have 920 degrees, and we want to find the coterminal angle for this angle. So, we are going to, again, look back at our rules, which say that you can add or subtract multiples of 360, as well as your coterminal angle must be between 0 and 360 degrees. So let's start out. So our first rule states that we can add or subtract multiples of 360, meaning that we can do 360 times 2, 360 times 3, and add or subtract that from our given angle. That means that we can just try to think of a number that would be added or subtracted to 920, and that answer would be between 0 and 360. In my opinion, what I think we should do is subtract 360 degrees by 2, which is 720 degrees, meaning that here we can subtract 720 degrees from 920 degrees, leaving us with 200 degrees. If you guys just heard the police sirens in the background, there was a police chase going on apparently, but they caught the guy, which is good. Let's continue with our coterminal angles. So now that we have 200 degrees, we have already satisfied the first step, which was to add or subtract by multiples of 360 degrees. We also satisfied the second step, which was that our coterminal angle must be between 0 and 360 degrees, and 0 is less than 200, and 200 is less than 360 degrees, meaning that 200 degrees is the coterminal angle for 920 degrees. Great. We have just gone through how to get the coterminal angle in degrees. Now how about we find out how to calculate it in radians? We're going to do the same thing. Let's get the rules for radians. So in radians, you can add or subtract multiples of 2 pi over 1. Then your numerator must be less than 2 times your denominator. Another rule that we have when dealing with radians is that our radian value has to be in between 0 and 2 pi over 1, or 2 pi. So now let's go ahead and do some practice. So in our first practice problem, we're going to get 45 pi over 7. Now, if you guys remember from elementary school, in order to add or subtract fractions, you need a common denominator. In this scenario, we have a denominator of 7. So again, as we said in our first rule, we can add or subtract 2 pi over 1 or multiplies of 2 pi over 1. So now that we know that we need a common denominator, we just need to get that done. And in order to do that, we just multiply by 7 over 7, giving us 14 pi over 7. You can now see that we have a common denominator of 7. And now, since we want to get it in between 0 and 2 pi, we need to subtract. And now we're going to minus 14 pi over 7. So 14 pi over 7. And 45 minus 14, we're only dealing with the numerators, that's what is changing. Denominators are staying the same since we are adding or subtracting. 45 minus 14 is 31 pi. Now we can subtract 14 pi over 7 one more time, giving us 17 pi over 7. Now we would subtract 14 pi one more time, and that means that we would end up with 3 pi over 7. Now that we have calculated 3 pi over 7, let's see if it fits all our rules. We did add or subtract multiples of 2 pi over 1, so we can check mark that off. Our numerator has to be less than 2 times our denominator, so let's see if that works. So our denominator here is 7, so 7 times 2 equals 14, and 3 is less than 14. Great. And it has to be in between 2 pi over 1, so 2 pi over 1 and 2 pi over 1. So if you do this, 2 pi over 1, and you make it with a common denominator, you'd get 14 pi over 7, and 3 pi over 7 is less than 14 pi over 7, meaning that we have satisfied all the rules and that 3 pi over 7 is the coterminal radian to 45 pi over 7. Great. Let's do one more practice problem. The second problem, we were given negative 60 pi over 8. We're going to do something similar to what we just did in practice problem number 1. That being getting a common denominator, since we are adding or subtracting, and a common denominator, and remember we're adding or subtracting 2 pi over 1 or its multiples. And in order to get a common denominator, we're going to multiply by 8 over 8, giving us 16 pi over 8. Okay, so this is what we are going to be adding or subtracting. So now we have a negative, and remember we wanted to get in between 0 and 2 pi over 1, or just 2 pi, meaning that we're going to be adding. So we're going to be adding the 16 pi over 8. So add 16 pi over 8. Negative 60 pi plus 16 pi gives us negative 44 pi over 8. Again, we're going to be adding 16 pi over 8. And negative 44 pi plus 16 pi gives us 28 pi over 8. And again, we're going to be adding 16 pi over 8, which gives us negative 12 pi over 8. We're almost there. Again, we're going to add 16 pi over 8. Negative 12 plus 16 gives us positive 4. So we have 4 pi over 8. And again, let's see if we satisfied all our rules. So our first rule said that we had to be in between. So our first rule said that we can add or subtract multiples of 2 pi over 1, which we just did, as we calculated right here. Next, we have to have a numerator which is less than 2 times our denominator. So our denominator is 8. 8 times 2 equals 16. 4 is less than 16. Great, we just satisfied the second rule. Now, the third rule says that our answer needs to be between 0 and 2 pi over 1. So, we can check that because 2 pi over 1, and again, just get a common denominator in order to make it simpler for you. That would be 8 by 8, giving us 16 pi over 8. 4 pi over 8 is less than 16 pi over 8. It is positive, meaning it is above 0, and it's less than 2 pi over 1, or in this case, 16 pi over 8, meaning that the coterminal radian to negative 60 pi over 8 is 4 pi over 8. If you believe that this video helped, please consider to like and subscribe. Also, you can leave a comment for future recommendations for videos. And remember, if you hit the bell icon, you'll get updates and notifications for my upcoming videos. Thank you.